Okay, so the question is, you got a fence, and the fence takes up area of 200 meters squared, and the perimeter is equal to 70 meters. Okay? It says there's a rectangle, first of all, okay? So what I'm going to do is I'm going to name x's and y's, okay? So essentially, let's talk about what area really is. Area is actually x times y, which is my length times width, but I'm just going to write x times y, because that's my length and width right now. So area is x times y, okay? And perimeter is equal to, 2x plus 2y, okay? So we have our numbers there. Now what's interesting about this is I can actually plug values in, okay? For instance, P and A is, that's right. So let's plug those values in. I got 200 is equal to x times y, or xy. Okay. And in this one I have 70 is equal to 2x plus 2y. Okay, what I'm going to do is, mainly because I'm used to working with x, is these are two different equations, okay? We'll call this equation 1 and equation 2. Now, do you remember in grade 9 where you did solving through substitution? When you have two different equations, you set one equation equal to one variable and solve for it. And you substitute it in for the other and solve. So, for instance, in this one, I want to get rid of the y here. So, I'm going to set equation 1, y equals, I'm set equal to y. Then I'm going to plug that value in for y in the next one and see if I can create a quadratic. What I'm trying to do is create a quadratic formula right now. Okay? So, in order to do this, I bring 2x to this side, so I've got 70 minus 2x equals 2y, and then I divide everything by 2. So I have 70 minus 2x divided by 2 is equal to y. And what I actually can do is I can simplify that too. This is actually 35 minus x equals y. Does that make sense? You know how I got from this step to this step? Okay, good. Okay, so y is equal to 35 minus x. So what I'm going to do now is my area, 200, is equal to x multiplied by 35 minus x. Okay? Yeah, it's positive, okay? So now what I have to do is distribute my x. So I'm going to distribute my x. I get 35x minus x squared.
This is where it gets stuck.
Equals 200.
And then you put it to the other side.
Right, 200 to the other side, so 0 is equal to,
Negative x squared.
yeah, let's rearrange this. Negative x squared plus 35x minus 200. Now,
So do you put it in the quadratic?
yeah, I can put this in the quadratic formula now. Okay, so my a value is what?
-1.
Yep. A is -1. B is, yep. And C?
-2.
Yeah, it seems like you know what you're doing there. Okay, so we'll put this in our quadratic formula now. X is equal to negative b plus or minus the root of 4ac divided by 2a. Does that make sense so far? Okay, so let's plug our values in. We're going to get negative 35 plus or minus, I don't know what 35 squared is, but
1,225.
okay, well let's plug them in and start. 4 times -1 times 200 divided by -2. Does that make sense to you? -2? I just did -1 times 2. Okay. So, you help me out here with that calculator. Plus or minus. What's the root, or what's 35 squared?
1,225.
Okay. -1 times -4 is positive 4. Positive 4 by 200 is 800. So plus 800.
Isn't it -100 because there's two negatives? This led to hundreds.
Oh, you're right. I didn't write that up here, so I read it wrong. So that's -200. So that becomes, this becomes a negative, which then makes that a negative, so it's minus 800. Does that make sense? Good, you noticed that. I only wrote it as positive 200. Okay, so then we have negative 35 plus or minus the root of 425. Oh, you already got it? Good. I'll do this next one. So now, 20.6. We're going to do this two ways. Oh, then we got to split it again. Okay, we're going to do it two ways. Negative 35 plus or minus 20.6. And just because you said your teacher likes things in radicals, our other option is negative 35 plus or minus. Okay, does 25 go into 425? Evenly? 17 times. So we have root 17, root 25. Okay? Divided by negative 2. Does that make sense what I'm doing with my radical right now? Mm-hmm. So what I'm going to get is negative 35 plus or minus 17 is a prime number. Okay. So I can't split 17. Only one 17. So 5 times root 17 over negative 2. Does that make sense? Okay. So now I have these two. Now normally they split, right? So we're going to get two answers. So we're going to get negative 35 plus 20.6 divided by negative 2, and we're going to get negative 35 minus 20.6 divided by negative 2. Our first answer is going to be 15. Negative 45.3. What's our second answer going to be? This one should be positive.
Okay. What should be? So it's 27.
Okay, 27.8. Okay, now what's important here is, actually what we'll do is also do it as a radical quickly. Split negative 35 plus 5 root 17 divided by negative 2. You really can't do anything. And you really can't do anything over here. So it's really not what we want. We really don't want an radical answer here. We're going to be looking for this because we're trying to find dimensions of a fence, and this is a ridiculous number to give to somebody. Oh, I'd like my fence to be negative 35 plus 5 times root 17 divided by negative 2 the distance. That doesn't make any sense. So what's important here is we relate it back to a fence. So we solve for x. That means our width of the fence we've just solved for. That's only one of the dimensions. The options are negative 45 meters or positive 27.8 meters. Which are two options? Yeah. This one is illogical. You can't have negative for a measurement, right? So our x is 27.8. Okay? Yeah. So we have x is equal to 27.8. Great. I can find my y very easily. I'm just going to plug x into my area formula again. Okay? We'll do it in blue on this side. So 200 is equal to 27.8 times y. Y is equal to 200 divided by 27.8. What is y? 7.1? Let's say 7.1. So obviously this fence isn't drawn to scale because the y is longer than the x, but that's not the case. If one dimension is 7.1 meters and the other is 27.8 meters, we'll get an area of roughly 200, and the perimeter will be roughly 70. Now we round it. That's why I'm saying roughly. It's not going to be exact. So for instance, if you multiply those two numbers together, what did you get? Yeah, so you're off a little because we rounded early. There's supposed to be quite a few other numbers after that. And then if you added up the perimeter the exact same way, 69.8, yeah. So because we rounded, it's not exact, but that's the ideal. See, those are two very close measurements. Does that make sense? Okay. Question 3, they give us an equation, right? It says h is equal to negative 4.9 t minus 2.8 physics question plus 39. Okay. They say t represents time. What is this? A baseball. Okay, so a baseball has been hit. H represents the height in meters, and t represents how long in time. So 3a question asks us how high off the ground was the ball when it was hit? So when a ball is hit, what are they referring to in terms of time? At what time is the ball hit at? Do you know? Let's say we're playing t-ball, okay? And the ball gets hit. At this point in time, technically how long has it been since the ball's been hit? The ball's sitting right here. 0. 0 seconds. So essentially, I'm going to replace t with the number 0. Okay? So, h is equal to negative 4.9. 0 minus 2.8 squared plus 39. Okay? This becomes negative 4.9 times negative 2.8 squared plus 39. Can you get that number there? It's going to be negative 4.9. 20 times 2.8, I'm sure it is.
7.8.
Alright, and then multiply that by negative 4.9. Okay, 38.4. Or wait. Okay, 38.416. Okay, perfect. Plus 39. And this is technically negative, right? And this is meters, right? Okay. So the ball was 0.584 meters above the ground when it was hit. So in other words, it's roughly 58 centimeters above the ground when it was hit. That makes sense. 58 centimeters. That seems pretty low. Swinging at a grounder on this. Okay, so that's the idea. Okay, so how high was the ball when it was hit? That's how high it was when it was hit. Time was at 0. Okay. 3b. What was the height of the ball after 2.3 seconds? And it's on its way. Oh, is it on its way up or down? Ah, that's a good question. Okay, do you think you can try this one? Time is 2.3 seconds. Yeah. So do that. So this here and this here are actually my coordinates of my vertex. Okay, my x and y value. My y value of the vertex is strictly whatever this number is on the outside, and that's when it's in this form. This is called vertex form. Usually they call this an A. Have you seen this before? H and K. Is that what you guys use? Okay, good. Sometimes you use different letters, different books. So the K strictly refers to the y value of the vertex. So our y value is 39. So that's the maximum height. Ball gets up to 39 because a vertex is going to be the height, top height. And though it says negative 2.8, the actual x value, or h, it's always the opposite of what the h says. Okay? So because it says negative 2.8, yeah. So our vertex is 2.8. So this is our max height. After 2.8 seconds, the ball reaches 39 meters. So you're right, because it's before 2.8 seconds, it's still on its way up. Okay? Okay, so this is 3b, correct? And it says, when is the height 30 meters? So we replace h with 30. So I brought 39 over, I got negative 9, right? Is equal to this. Did you get that? Okay. Then I got to divide by 4.9. Because it's negative, what did you get? You got positive 1.837. So that's negative 9 divided by negative 4.9. 1.837. Okay. This is equal to t minus 2.8 squared. Okay, so this is the difficult part. In order to get rid of this squared, I need to square root both sides. I need to get the square root of this and the square root of that side. So the square root of 1.837 is actually equal to t minus 2.8. And what happens is from here I get two answers. Okay. What's the square root of 1.837? What did you get? 1.
I got 1.355.
Okay, so you're going to get positive 1.355 is equal to t minus 2.8, and you're going to get negative 1.355 is equal to t minus 2.8, and then you're going to solve for the two t's. So one of them you brought them over and you got 4 something, 4.155. That's one of the times. What was your other time?
355.
Okay. So according to this, almost 1.5 seconds after his hit and a little after 4 seconds after his hit, it reaches 30 meters, which makes sense, right? Because if we have a parabola, remember at 0 it was at like 0.5, right? It gets hit, comes down. We know the max height is 39. So say this is 30. Well, we now discovered that's at 1.4 seconds roughly and at 4.1 seconds, which makes sense because remember we know our vertex is at 2.8, right? So we know it's a little before and a little after that because it goes up past it and then back on the way down it hits 30 meters again. Does that make sense? Good. Okay, what's the next part of the question ask? Okay, so actually this one's pretty easy. Domain and range deal with restrictions on a function. Now because this has arrows, what that means is this is going to go upwards forever and downwards forever. It also means it's going to go right forever and left forever. So domain deals with our x, right? So domain and range deals with our y. Well, in both these cases, because it's a continuous line, okay? Yeah, x is element of all real numbers, x is every real number, and y is every real number.
Is that it though?
That's the domain and range for this one.
Okay.
It's really straightforward, it's a straight line. It just goes forever. It exists at all points. Okay? Let's try a different one. Okay, say we're dealing with this function now. This one's a little different. First of all, it's a straight line. So let's deal with the domain. Again, because it is a straight line, it exists at every single x coordinate between there. So we're going to say x is the element of all real numbers, but we put a line because it has restrictions. It also only exists between 3 and negative 4. So we know that x, okay, here's my negative 4, x and 3. X is greater than and equal to negative 4, so in other words it goes this way. And it's also less than and equal than 3. So those are our restrictions. Essentially you get the two endpoints, put them on the side, put x in the middle, and put two arrows like this. Okay, so it's between those. Okay. Our range is a little different actually. Our range, there's only one value for our range. It's not the set of all real numbers.
2.
Yeah, our range is 2. So, sorry, usually you put range as y equals 2. That's why normally they don't use equal signs here. They usually use colons, but I'm not sure what they've shown. Usually they go with range. Yeah, so range is y equals 2 in this instance. It only exists on the number 2. It's nothing higher, nothing lower. Does that make sense? Try this guy. It's an absolute value.